All right, hey guys, it's me again, and it's reset as I'm really sorry, trying to reset like every time. So the reason why I'm getting reset is I was a little bit busy with something else, and now I try to understand. But after I understand that, when I try to make a video, the time is already passed. So still, even the time is passed, I try to make the previous day coming back to solve by then. Also, this video solution is heavily referenced on the Leetcode.io. Shout out to the guy, Leetcode.io, who is making this solution like easy to understand. Without him, I would be struggling alone, and I want to be able to make this video. I'm gonna drop his YouTube channel link in my description, and have a look and like and subscribe his channel. So today Leetcode problem is count and cut the cells in a grid. So the question is a little bit interesting. So we're given two integers m and n, representing a zero index m x n grid, and we also given two dimensional integer arrays, guards and walls. So where guards equal to the rows and walls is rows and columns. So represent the position of I index of the guard and j index of the wall respectively. So I'm gonna move to the explanation in here. So when we check the HTML1 in their question, so their explanation is pretty straightforward. So let's say we have a guard in here. That means the guard can see through left, right, back, and forth. Consider this one is a front, this is a fold. So since there's nothing in the behind, so there's nothing he can see for the guard. So the same, so this is a wall. W represents the wall. So if there's a wall, the guard even to see through it for sure, unless he's a superhero or something. And then there's a second guard in here. So you can see the left and right all the way till the wall, and then back and forwards. So there's no guard in the third column, which is index 2, and then there's one guard in the fourth column, which is index 3. So it's the same for the guard. So this guard can see like back and forth, left and right. Since there's a wall, the left side of the guard, so there's no reason for the guard to see. So that solution we need to return is we just need to calculate the unguarded cell, which means that the guard cannot see. In our case, it will be the 1, 2, 3, 4, 5, 6, and 7. Yeah, that's the reason why the HTML1 output is 7. So in this case, this one is also straightforward. Since the guard is surrounded by the walls, the answer is 4. So to walk through that, my first approach is I was thinking like create artifact grid, m like rows and column given by the question. After that, what we're gonna do is I will have initial values. Let's consider like everything is 0 for something. Let's say like 0 for free or whatever, and then 1 for guard, or another as we can make thinking is maybe we can use a string letter. Okay, like instead of explanation through, let's explain a little bit and code a little bit, so that would be much easier for us to explain. So before we start coding, so we need to make sure like which one represent the free. Let's call it like f if a free, since it's free represent the first initial. Then we have a guard, that means like g represent the guard, and then we have a wall where represent the w, and then we have a cell. So let's go like guardable is a cell. So my first approach is we're gonna need to create the one grid. So that grid is a m and n two-dimensional grid provided by the imports in here. So let's create the array of repeating array, which will be the column in our case. So that is repeating of the f, since we are going to use a character for the collision check-in, and then count will be the n, and then this is for the creation of the each row in here, and then for the total array of the rows will be the count of m. Didn't I have a lot of parentheses in here? Okay, that much makes sense. And then let's call, we have one variable called reset is 0, and then we will return the reset. So while we are explaining through, we still need to fill up our grid with the requirement. Okay, let's create the one grid in here for the better presentation. Okay, I will create the grid in here, but it might not be exactly the same as here. Okay, sorry for the drawing. Okay, I will try to create a better grid for explanation. And then, why it's so ugly? Okay, let's say we have like this, and then like this. 1, 2, 3. If I have an OCD, bear with me for a moment. 1, 2, 3, 4, and 5, and 6. After that, I'm gonna create another 1, 2, 3, 4. So we don't need that much long anymore. And then make it short. Oh my gosh, I should have prepared this before I make it a video. Sorry about that. Okay, I just want to represent like what I am doing by creating the grid in here. Since we are creating a grid, so that means like we are limited to the inputs and outputs of our process. And then for initial, we are putting f in almost everywhere. Let's create things called f. Okay, let's make it green since it is free. And then that is like almost everywhere. Okay. And then, okay, I hope you guys got my point. So that is what I'm doing now. And voila, look at me. What a great illustration. Okay, then for the jokes, since we have created all the free cells, we need to fill our guards in our grid. So what I'm going to do is, let's go like, when you go through the guard position, let's go guard pause, then guard, because guard is the exact keyword in here, so we are not allowed to use singular guards in here. And then what we need to do is we need to update the grid of guard position 0, which would be the row, and then okay, bear with me, I'm gonna name G for the better usage. Then guard of 1 will be the G. I'm gonna feed that with the G. That means like we are going to fill all the G's in here. That means since our input in here will be the 0, 0, 1, 1, and 2, 3. So 0, 0 will begin the guards. Okay, let's make the guards orange color, and then we'll begin the G. And then 1, 1 is here, so it's pretty straightforward. It will be here, and then next will be here. So that is what I'm doing right now. Okay, enough for that. And now for the next step, all we need to do is we need to fill the wall in our grid. So what I'm going to do is same as the previous approach. I'm going to update the wall of 0 is a row, and then wall of 1 is a, and I will fill that as W. So that's also straightforward. So 0, 1 to 2, 1, 4. 0, 1 is this one. We'll begin the wall. Let's make it black since this is a wall. Okay, go back to here. 0, 1, 2, 2, 0, 1, 2, 2 will be here. So will be here. Next will be the 1, 4. 1, 2, 3, 4 will be here. Alright, so we are pretty much done for it. So after filling all our requirement, what we need to do is we're gonna look at the guard position, and then yeah, we need to check the guard position. So I'm going to check like it's a free or you have a guard. Okay, let's go through it. So let's consider that we are doing it here. So the guard will be checked all the way down, left and right, and then back and forth. That's what we're going to do in this step. So since the guard can see, so all this will be blocked. So go back to the code. So I think in that case, I would prefer to create the nested function, which is an inner function in Swift. And then for this inner function, we were allowed to access the grid without having a memory address in Swift. Let's call it like mark guarded, but the name is a little weird. Never mind. And then we will have a row, which will be the integer, and then column, which will be the integer also. So inside that, what we are going to do is if row in row plus 1. Why we need to check the row plus 1? Let's say you are in the guard position. You are pretty sure your position is not the free cell. So that's the reason we are going to do the plus 1. So plus 1 till our column state, which is the M in here. So M represent the grid. So we have a 4M. That means like even though we are calling like a row, but we're going down like 0, 1, 2, 3, which is the 4 rows in total. And then inside the fourth block, what we're going to do is we're going to upgrade that as a guardable. So guardable mean like it's a cell. Okay, how I'm gonna update? Let's call it grid of row and so row mean like since we are going through like from top to down like 0, 1, 2, 3, and then the column we're gonna need will be here since we are only touching the one column, not touching all the columns at the same time. And then I will update that with our cell. So even though it is called cell, the name is a little bit weird. Let's call it the B, which be block. Okay, while checking that, we still need to consider the to approach. So if it is is a free or if it is a guard contained there, we're gonna break through it. So what I was thinking if f and g contains grid of our going down row and column, I'm gonna break it here. The reason why we need to make a break is if you saw the free or guard, so we don't need to continue doing that. So that is the approach I'm doing right now. So the same, I think this is will be the very long method, I would say. So after done for the looking up and down, so we still need to check that one more thing, which is going from the reverse way. So if I say reverse way here, I will write the code and I explain in detail. Let's call it like 0 to the row. So that means we are going from 0 to row, but I want it fast. So that will be array, I would say. And then what I'm going to do is grid of row and column will be the block. So B mean like is a block for the approach. Yeah. So if it is block mean like it cannot access. So what I'm doing here actually is I'm going through from the 0 to row, which is a row in our case will be the okay. I need to explain more a little bit today. So what I'm actually planning to do is planning to call that method of Unguarded in here. Let's call it guard position in guards. So that means we are just going through all the guards, and then let's say this is 3 guards. So if it is 0 and 0, we're gonna pass 0 and 0 in the rows and column in here. Let's call 0 and 0. So in that case, 0 0 is doesn't make sense. So we need to think for another approach. Let's call it 1 1. So my original idea is to call invoke the mod guarded in here, which is the guard both of 0 and guard both of 1. Oh man, I first time hate the Swift. They have a lot of reserved keyword now. So that means if I pass the guards two-dimensional arrays in here, let's call it is a 1. So in 1 here, that means 1 1 mean like I'm seeing the second guard. So if I'm the second guard, what I'm doing is 0 to 1. Okay, in that case, that would be 0 0 dot dot like this. So it will actually true like one time, but since we want the reverse, so what it's going to do is only 0 one time. So if it is go reverse, what we're going to do is we're going to see from the position to tilt the left, and then this is to tilt the right. So that is what I'm doing right now. So consider you're this guard, and then you're gonna see tilt this left side. The same issue, since if we saw the free and guard, we can just break the condition here. So if we see the free, or we see the guard, what we're going to do? It's pretty simple. We're going to make a break from here, and we're going to update the remaining into the break. That means that it's block. Okay, next step. After done for the row part, even though we're seeing the row, we are simply doing the going up and down. So the previous function, not the function, the previous logic that I created in here from line number 25 to 26 is simply doing from God to see up right. I hope you guys see it, since my item is pretty weird. If it is God is here, so it's going to block all the way down from here to there. And then what next? What we need to do is we're going to approach for the column. So for the column, what we need to do is column plus 1. The thing, since you're standing here, you really want to see your left and right for sure. So we're going to do the plus 1 and see all the way right and then all the way left. So I'm going to put the column plus 1 all the way to the end. So n in our case mean like here, which is to the column number. So we want to go through like all the way to the right. So let's say you're the guts in here. You want to see from your position to all the way right. All right. So if like that, we can approach. What we're going to do? So we're going to check if free and gut contains the grid of rows and column. In this column, I'm going to break, and then if grid of row and column, I will update as a block. So the same broach, what we need to do is here, just copy and paste. That will be the column. What do I need to do is 0 dot dot column. So we're just going to see all the way to the left from the current position. After that, that will be the same as the previous one, row to column. And then if I saw, I will update the row and column to the B. Alright, I think I'm pretty much done for the logic of updating the break in here. So just come back to our previous example that I draw, even though my drawing is very ugly. Thank you for seeing all the way through. So if I'm the gun, I will block all the way down, and then the wall, we don't really care about it. So this is a wall, so this is a gun all the way down, up. So that's what I was doing for the first do for loop in here. So the second later do for loop is doing like block all the way from here to there, here to there. Yep, I think that is where help us to create the error. So what we need to do is we can find the freeze in our grid, and that will be our answer in our case. 1, 2, 3, 4, 5, 6, 7. So after returning all through, what I need to do, I need to go through the grid for one last time, which is going to compute the number of free cells in row. Or I'm gonna compute like if like number equal to 3, I'm gonna increment the result into 1 and then just return the result. Let's see is that work or not. Alright, so there's something really wrong. Let me check what did I do wrong. Oh, check the guts and wall only. So this is not going to be the free, it should be the wall. That's the reason. Silly me. That's why the explanation is a little bit weird. Let's try again. And voila, I hope it's won't cost time limit AZ. And then the runtime is very awful. Alright, let's performance tune our solution. So I am strongly using the condense in here. That means like which is causing a lot of performance here. In our case, if I have to do like that, what I would do is I will create the one variable above. Let's call block, and then this will be set. I think that is similar to the previous problem. If we saw the guts and wall, we can stop doing it. So if we are using the array, so if we check the content, it's going to iterate from the beginning to the end. So that is going to take the O of n. So if we swap that with the set data set, that will only be the O of 1. I think that is the yesterday brooch. I also going to attach the documentation for that in the description for you guys. And then let's add it a little bit. Now it's a 4,200. Let's try it again. I hope it's drop minimum, but it's going not going to update a lot. Okay, 100 millisecond drop. Another approach. We are using the array, and doing the reverse is very performance rich, and that is not efficient for us. So in that case, we have one API from Swift, which is called stride. So we're going to use the stride. That way we're going to create the reverse array for us. So in here, how I'm going to tune the performance is using the stride from row minus 1, since we want to import the row to true. So there's a two approach in here. So if you saw it here, so there's a 2 and true. So if you use the 2, that is not going to include the, let's say you have a 0 to 5. If you use the stride from 2, so it will only going through from 0 to 4 only. So if you want to involve the 5, what we need to do is we need to use the stride function from true. That is going to include the 5. So in that case, since we want to involve the 0, we're going to use the true and then bind minus 1. And then for this one, for column in strike from column minus 1 true 0 by minus 1. Let's try to run again, and crossing my finger, I hope it will tune the performance a lot. Okay, what did I do wrong? Let me see. The operator can be separated from its unary operator. Okay, silly me. There's extra space in here. Oh, nice. So what we have done is we have improved the performance like 40 times better than the previous solution by using the stride. All right. And then I will really try not to reset dates straight again for tomorrow. And then thank you and see you in the next video.